Hi there. We talked today in class about finding the area of a region between two curves, and this draws on our understanding of integrals that we built in Unit 4. In Unit 4 we looked at what happens if we have a curve, such as this one, and we wanted to find the area of the region from A to B. From A to B. And we looked at initially in Unit 4 using geometric figures to kind of cut that up or to make approximations. For example, I could draw in a trapezoid, and while it would be an over approximation because there is some space that the trapezoid includes that isn't included in the shaded region, so it's an over approximation, it would get us close at least. And then we looked at, well, how can we make it more accurate? Well, we looked at what if we cut them up into rectangles, right? And what if we made those rectangles successively smaller and smaller and smaller until they became so infinitesimally small that we just ended up with a solid mass, and we called that our integral from A to B of f of x dx, and we used our fundamental theorem of calculus, right? This is our base and our height being multiplied together from A to B. Okay. And again, that was all Unit 4. So today we threw in a second rectangle, or sorry, not a second rectangle, a second curve. And we said, well, how do we find the region between those two? Right, so we have here f of x, and we have our g of x, and we're trying to find the region from A to B. So A looks like is that intersection point, B is right here, and we're going to be finding the area of that region. Okay, well, how do we do that? Well, I know that we can take the integral from A to B of f of x dx, and if we took the integral from A to B of f of x, here's f of x, that would give me this entire region, everything from f down to the x-axis. Give me that whole area. That's a little bit more than I want, right, because that includes the unshaded region, and so how can I get rid of that unshaded region? Well, that unshaded region is the integral under my g of x. It's the area under my g of x, and so that would be subtracting away A to B of g of x dx. And that's notated like you see up here. Area equals integral from A to B of f of x minus g of x dx. Off to the right here we have our steps 1 through 7. This worksheet is on my website, and I would encourage you to download it so that you can follow along with me. Stopping the video if you're starting to get the hang of it, I would encourage you to try a problem on your own. That way you have an honest evaluation for yourself about what you are actually understanding. And then you can start the video again if you get stuck or if you're ready to check your answer, and then you can use my guidance from there on out. Again, you need to make the choice that will best suit your needs and best suit your learning style. Okay, so we're starting here on number 1, which says find the area between y equals x squared minus 1 and the x-axis. Okay, and so we're going to start with graphing the functions. That way we have a visual of what we're looking for. Okay, and so when I plot this on my graphing calculator, right here I have x squared minus 1, and then I guess you could put the x-axis in. X-axis is y equals 0, but there's not really any purpose to plotting that, although I guess technically if you wanted to put into y2 0, you're more than welcome to do so. And my window right now is -5 to 5 for both my x and my y. So I'm going to go ahead and graph that, and this is the graph that I get. Nice parabola. And I'm just going to sketch that. Okay. So we are finding the area of this region. Well, first of all, we need to find our left and right, our lower and upper bounds are A and B. And those bounds are at these two intersection points, the place where my y equals x squared minus 1 intersects with my x-axis, or y equals 0. So you have two ways of doing this. One is using your understanding of math. If two graphs are intersecting at that point, they have to be equal, right? So at these intersection points, x squared minus 1 has to equal 0. Well, if x squared minus 1 equals 0, what does x equal? Well, x has to equal plus or minus 1. Okay, positive or negative 1. Those as our limits. Okay, the other option would be using your calculator. Where the graph touches the x-axis is a 0. So when we go to F5 on the 89 or second calc on the 84 and down to number 2, which says 0, hit equals, and it'll ask you for your lower bound and your upper bound, and you'll get negative 1. Okay, and then you would do the same thing on the other side. Lower bound, upper bound, and it'll give you 1. Okay, so sure enough, our lower and upper bounds are negative 1 and 1. So to find the area of that region, we're going to do our upper graph, our f of x, minus our lower graph, our g of x. Okay, my upper graph here is this horizontal line, which is x-axis, which is y equals 0. Okay, minus, and my lower is the curve, it's the parabola, which is x squared minus 1. So again, our f of x minus our g of x, our upper minus our lower. And then we integrate. We have negative 1 to 1. The 0 minus anything, the 0 is just going to go away, and so we're going to distribute that negative in. We have negative x squared plus 1. Power rule. So we have negative 1/3 x cubed plus x from negative 1 to 1. Plug in your f of b, so we're at negative 1/3 plus 1 minus, plug in my f of a, which is 1/3 minus 1. Okay. And so then we'd have, this is 2/3 minus a negative 2/3 minus a negative is a positive. And so our answer is 4/3. Okay, number 2, we have find the area between f of x equals x squared plus 2 and g of x equals negative x minus 1. And so again, we're going to start with graphing them. So let's go to y equals. We're going to plug in x squared plus 2. I'm going to go ahead and notate that I put that into y1. And I'm going to put in negative x minus 1. And I'm going to notate that I put that into y2. And they're telling us that we're going to find the area from 1 to 2. Okay, so let's go ahead and graph that. So that's what you should get on the graph. A quick sketch of that, just so we can see what we are working with. Again, doesn't have to be perfect. And we're finding it from 1 to 2. Okay, and so our rectangle in this case is going to go all the way down, upper minus lower. So our bounds, they were given to us, 1 to 2. Our upper graph is that quadratic, x squared plus 2, and our lower graph is the line, which is the negative x minus 1. So we have integral from 1 to 2 of x squared plus 2 plus x plus 1, distributing the negative, which is integral from 1 to 2 of x squared plus x plus 3. And we apply fundamental theorem of calculus. So we have 1/3 x cubed plus 1/2 x squared plus 3x from 1 to 2, which is 8/3 plus 2 plus 6 minus 1/3 plus 1/2 plus 3, which all of that equals 41/6. So that's the area between the two curves. Okay, number 3, we are finding the area bounded by y equals x cubed minus 3x squared plus 3x and y equals x squared. So again, let's graph it first. Just a reminder, I encourage you, if you ever feel so inclined, pause the video, see if you can solve it on your own. We're going to put in our x cubed. Go ahead and slide this up. X cubed minus 3x squared plus 3x and our x squared. And I'm going to go ahead and notate, I put this into y1 and this one into y2. Okay, and my window on this one is going to be -10 to 10. When we graph it, you get this picture. There's our cubic, and here's our parabola. And if you notice, there are actually two regions here. A small one, right, where it intersects, it looks like maybe about the origin, intersects right about here, so that's our first region, and then we have a second area with this latter piece. So let's go ahead and sketch that. Our quadratic and our cubic. And so two regions. Okay, two regions means two integrals, and those two integrals aren't going to end up being added together, right? Because together they make the area of the total region. So let's take a look at this first integral, or first region. Okay, so I need to find this intersection point and the middle intersection point. Intersections, 84's second calc, 85's is F5, and we have intersection, which is number 5. So again, 84 is second calc, 89's F5, number 5 intersection. It's going to ask you for your first curve and your second curve, which just means which two curves are you wanting to find the intersection of. In this case, we only put 2 into our calculator, so it's going to be the 2 that are there. So we can just hit enter, enter. If you had put more than 2, that's where notating comes in handy. You'd want to make sure you selected the 2 graphs that you were wanting to find the intersection of. Okay, and then it's going to ask for our lower bound and our upper bound. And our first intersection there is at x equals 0. And then second intersection, same thing. First curve, second curve, lower bound and upper bound. And our second intersection is at 1. Okay, now for that particular region, we need to look at what's our upper graph and our lower graph. What's this top curve? Which function makes that? And in this particular case, that top curve is made by our cubic function. And so my upper is x cubed minus 3x squared plus 3x minus my lower, and my lower in this case is that quadratic x squared. Okay, and then same thing for this second region. This intersection now and the top intersection, we already know this intersection is 1. And the top intersection, 84 is second calc, 89 is F5. First curve, second curve, lower bound and upper bound. And we get intersection at 3. And then for this second region, our upper graph in this particular case is the quadratic. And so x squared is my upper minus my lower, which is the cubic. Okay. And from there we can integrate. Okay, I want to take a moment and remind you of something that your calculator is able to do at this particular point in our journey. Obviously, this can definitely be solved by hand, and if you're wanting that algebraic practice, I might encourage it, just to make sure we're increasing our confidence in that area. So you'd apply power rule and then do fundamental theorem of calculus. But on both the 84 and the 89, you have the capability of calculating the integral. And there's two different ways of doing so. So I'm going to show you the first way with this particular problem, and then with the next problem we'll look at the other way. And so the first way we're going to look at is in our home screens. Okay, so once you have your integral set up like this, before you've actually applied power rule, if you go to your home screens, on the 84s, you're going to be clicking Math, and then you're going to scroll up to FN int. And if you have the new math script, it's going to pop up, be a very friendly looking integral. 83s, you're going to do the same thing, although you won't get the friendly looking integral. You're going to get more like what the 89s are going to see. Okay. 89s, you're going to hit F3, which gives us calc. You're going to come down to number 2 and say integrate. 84s, I think you can guess from here on out how to plug in. So let's go ahead and finish the 84. 84, we're going to do x cubed. We're going from 0 to 1, so 0 to 1 of our x cubed minus 4x, oops, make sure to come down out of the exponent, minus 4x squared plus 3x dx. And when you hit enter, you get 0.416666667, and if you, so 6 repeating, if you want to see what that is as a fraction, you hit math. So I'll go ahead and show you where that is. You hit math, fraction, so it's going to be taking that answer and it's going to be turning it into a fraction, and you get 5/12. Okay, 89s, I'm going to use 89 to demonstrate this next one. 84s, you've now seen the process, so it would be the same one for the second integral. 89s, we input this way. So you're going to put in your function first, right, which would be negative x cubed plus 4x squared minus 3x. We're going to say comma x, saying we're taking that integral with respect to x, right, dx. So comma x, comma, and then we're going to put in our bounds, 1, comma, 3, and then end parenthesis. When you calculate that, you get 8/3. Okay, but these are just sub-answers, right? 5/12 is the first piece, 8/3 is the second piece. Together, they'll give us our final answer, 5/12 plus 8/3, which 5/12 plus 8/3 equals 37/12. Okay, on the back, number 4, we have find the area bounded by y equals cosine x, y equals sine x. And so if we graph that, equals, I'm going to go ahead and notate, I'm going to put cosine x into y1, I'm going to put sine x into y2. And my window is going to be from negative pi over 2 to pi over 2, because we have two vertical lines that form the other bounds, negative pi over 2 to pi over 2. And I know cosine and sine don't get very big, right? They alternate between -1 and 1, and so I'm going to go ahead and make my y's not quite so large. I'm going to make them -2 to 2 and graph it. And then the same thing on the 84, we're putting in -pi over 2, 2pi over 2, -2 to 2. Okay, and they'll get the same picture. Okay, so we're going to go ahead and sketch that. So we're finding this area here. And so again, we're going to need to find this intersection point, right? Because our first integral, we have two regions, our first integral is going to go from that -pi over 2 to our intersection point. And so you can use the intersection button, although it's going to give you a decimal. If you get a decimal, you want to make sure you're careful to not round or to truncate at that point in the problem, right? The sooner you round or truncate, it's going to skew your answer, and we need our answer to be accurate to 3 decimal places. So we're going to go ahead and apply our knowledge here. In this case, we have cosine and sine as our two graphs, and at this intersection point, cosine and sine have to be equal. It's the only way they can intersect. Well, we know where cosine and sine are equal. Think about your unit circle. Cosine and sine equal each other at pi over 4. Okay, and so this second region is going to be from pi over 4 to my upper bound, which is pi over 2. For the first region, this upper curve, this upper graph, is going to be our cosine x minus our lower graph, which is sine x. And our second region, our upper graph, is going to be sine x, and our lower graph is going to be cosine x. Okay. And so then here's where the other way you can take an integral comes into play. Again, you could definitely do this by hand. Okay. But the other way you can calculate this integral is in our graph screen. We know from our 4.3 properties that we can split this integral. We could take the integral of cosine x and then do minus the integral of sine x. Okay, and so that's what we're going to be doing here. In your graph screen, we're going to find what is the integral from -pi over 2 to pi over 4 of cosine x. I'm going to show it first on the 89, and then we'll do this bottom one with the 84. Okay, so with the 89, if you go to F5 and down to number 7, which is integral of f of x dx, they're going to ask you for a lower and an upper limit. And this is where labeling your functions is going to come in handy, right? Because I need to make sure that my calculator is calculating this integral for my y1, right? Because I'm calculating the integral of cosine x, and so I want to make sure it's calculating the integral of y1. And up here in the top corner, that's where it's going to show you what your calculator is talking about. In this particular case, we're talking about 1, so we're good to go. If it had shown 2, right, then our calculator would be calculating the integral of sine, and we don't want it to calculate the integral of sine, we want cosine, and so then we just hit our up or down arrows to get it to say 1. Okay. And so then they want lower limit, which is our -pi over 2. They want our upper limit, which is pi over 4, and it will calculate that integral for you, which is 1.70711. We're going to do minus, we're going to do the same thing for our sine, right? Minus the sine piece. So f5 integral, but this time make sure it says 2 because sine x was my y2. And so then lower limit, negative pi over 2, upper limit, pi over 4. It'll calculate the area for me as negative 0.707107. And if you do 1.707 minus a negative, which is plus, you should get 1.70711 plus 0.707107. It should be like 2.414. Yeah, 2.414. Okay, so that's how you do it on the 89s. 84s, we have our graph here, and we're going to be calculating the integral. So we're going to do second calc, number 7, which is integral of f of x dx. And 84s, you actually have the function displayed up here. So we want the sine x function, right, because that's what comes first. This says cosine x, so I'm going to go ahead and hit my up or down arrow to get it to say sine x. Right? And then it wants lower limit and upper limit. My lower limit is pi over 4. And my upper limit is pi over 2. And it'll calculate that integral. And that particular integral is 0.7071068. And then we do minus, and we want the cosine. So same thing, second calc. We're going to do number 7. Make sure it's talking about cosine because that's what we want. We want our lower limit, which is pi over 4. And our upper limit, which is pi over 2. And it calculates that as 0.29289322. And so then when you do that subtraction, you should get, I think it's 0.414, 0.71068 minus 0.29289322. Yeah, 0.414 21356. Okay, and so then we're going to add these two together to get our total. 2.41422 plus 0.414211356, and we're going to get, now we can truncate, 2.828, which technically, just so you know, is our area should be 2 root 2. And when you plug in 2 root 2, just to prove it, you get 2.828. Okay, so number 5 is yours to try on your own. I would encourage the use of a calculator. Your answer when you get there should be 0.871 would be your truncated answer. And we will be going over that in class.